Hello friends, welcome back to Logic and Math. Today we are going to solve very interesting math Olympiad question. So as you can see, it's very complex looking one but very interesting one. We are going to use some deduction to find the go to our solution. So first of all, pause this video and solve yourself and then comment the answer. So let's start. Our question is 4 raised to the power 4k minus 4k square equals k square minus k. So after watching this, nothing is clicking in the mind. When we take even log, then we are going to get these complex terms on the left hand. We will get log 4 something. So but on the right side we are not left with any number. Like in the previous video, we were solving like it was getting like some numbers on the right side, so we were cancelling out. But log a over log b. But here there is no such case. So how we are going to solve this? Let's see. Here you will see some similarities, which is k square minus k square and again k. So on the left side we are getting 4 raised to the power 4k minus 4k square is equal to right side k square minus k. Now we are going to arrange this in the similar form of RHS, so that we can assume this value as something simpler, something simple letter alphabet. So on the right side, when we take 4 as common, minus 4 as common, we are going to get k square minus k, and on the right side k square minus k. Now let's assume this value something. So let k square minus k is equal to x. So our now this bigger expression simplifies to 4 raised to the power minus 4x is equal to x. Now this look little bit satisfying, and that yes, now the expression has become small. So again 4 can be broken down into more smaller steps, that is 2 raised to the power 2 over minus of 4x is equal to x. Now a raised to the power m dot n we are going to use, so we will get 2 raised to the power minus of 8x is equal to x. Now from here we need to use our some mathematical deduction to see or get that how our values are changing with the value of x. So what we are going to do is we are going to put the values of x as something like 0 and 1, and then we will see how the our left and right side are deviating, because from here we can see that this is decreasing function and this is increasing function. So there is the only one chance that they are going to coincide, and we do not know where they are going to coincide. So we are just trying to put this 0 and 1 and check whether our assumption was close or not, and accordingly we are going to decide what to substitute the value of x. So when x is equal to 0, LHS we get 2 raised to the power 0, which is 1, and on RHS we get 0. So here our LHS is greater than RHS. This is our first deduction. Now let's assume put the value of x is equal to 1. So when x is equal to 1, on the LHS we are going to get 2 raised to the power minus 8, which is same as 1 over 256. And on the RHS we are going to get that 1 only. So we have seen that as we have increased the value of x from 0 to 1, our LHS has decreased. But our LHS has decreased very significantly when it has gone closer to 1. So from here we are clear that our value of x is greater than 0 and it is less than 1, because ultimately we need to balance this left and right. We need to make the equate this left and right hand side. So now for again reference, let's try the value, middle value of this 0 and 1. So let when x is equal to 1 by 2, when x is equal to 1 by 2, we are getting LHS as 2 raised to the power minus 8 times 1 over 2. We are going to get 2 raised to the power minus 4, which is same as 1 over 64. And on the right side, we are getting 1 over 2 again. So from here, we can see that although we have decreased the value of x from 1 to 1 by 2, but still the our LHS is lower than RHS, lesser than RHS. So again we come to deduction that our value of x is greater than 0, but still it's lesser than 1 by 2, because we need some values that balances this equation. But although we have decreased this value from 1 to minus 1 by 2, our LHS is still lesser. So now let's try this value, middle value of this 1, 0 and 1 over 2. So when x is equal to 1 over 4, why we are trying so that we can get the reference point that between this our value of x is lying. So when x is equal to minus 4, we are going to get 2 raised to the power minus 8 times 1 over 4, which is 2 raised to the power minus 2. So 2 raised to the power minus 2, which is equals to 1 over 4, and our RHS is x, so it remains 1 over 4. So here our point have met. It means our value of x is 1 over 4, because our LHS is equal to RHS. So till here we have win our first battle, which is we have got the value of 1 over 4. But still our battle has got no conclusion, because our x is not the true value which we needed to find. We need to find the value of k, and we have assumed this k square minus k as x. So let's put it here. So we get k square minus of k is equal to 1 by 4. Now we need to solve this quadratic equation. So let's multiply 4 both sides. We are going to get 4k square minus 4k is equal to 1, or subtracting minus 1 from both sides, subtracting 1 from both sides. So we get 4k square minus of 4k minus of 1 is equal to 0. Now before going further, we should check the whether we are going to get a real solution or not. And for that we are going to check determinant, and for real solution it must be greater than 0. So determinant is given by b square minus 4ac, and b square is coefficient of k, and a is the coefficient of k square, and c is minus 1. So we get b square as minus 4 square minus of 4 times a is 4 and c is minus 1. So we are going to get 16. This minus and this minus cancel out, and plus 16. So we get 2 times 16, which is equal to 32. And as we are getting positive value of a determinant, it means we are going to get real solution. So now let's erase this part, and let's get to our answer. So now our quadratic equation is 4k square minus 4k minus 1 is equal to 0. Now we know that for solving this type of quadratic equation, we use the formula that k is equal to minus b plus minus under root of d over 2a, which is determinant same this value. So now let's put our value here. So minus b is minus of minus 4, and plus minus is this is same as 2 times 62. So 16 times 2, and over 2 times a is our 4, coefficient of k square. So we are going to get k is equal to minus and minus cancel out. So 4 plus minus, from here we can see that it is in the form of root of a dot b, and it is same as root a times root b. So our root 16 times root 2 over 2 times 4. And when we take 4 common here, we get 1 plus minus this 4 we have taken common, so root 2, and from denominator also we have taken 4 common, so here 2 and this 4 over 4 cancel out. So we are going to get k is equal to 1 plus minus root 2 over 2, and here we have won the our battle. So we have got the two value of k, which is k is equal to 1 plus root 2 over 2, and the another value is k is equal to 1 minus root 2 over 2. So now I am not going to check this, that whether the value is satisfying or not, because I am sure it's satisfying. You need to comment that after checking by yourself, that what do you think. So that's all. Thanks for watching. And don't forget to challenge your math buddy.